Hello my dear friends, welcome to IMS Academy. I hope you people are doing good, and we have been doing this foundation series since the last week, and I'm already into a topic which is stress transformation, and today also we will be discussing that topic and further going into as you can see the title, we will be discussing the concept of Mohr's circle as well. And you people know that whether it is in the whether be it a semester examination or gate examination or any other examination, this topic Mohr circle and its relation with stress transformation is so important, right? So without wasting any time, let us quickly start with the session. So just a brief recap I'll help you, that we started with this general state of stress, right? So you can see 3 principal stresses, 6 shear stresses, but 3 independent shear stress. So that means total 6 independent stresses, and then we have reduced it to plane stress condition. So in plane stress condition, we will be talking about only the third coordinate system stresses. Thank you, Matan. So third coordinate system stresses will be completely 0. So that means Z stresses will be 0. That is called the plane stress condition. And then this plane stress condition, how it is represented in this 2D format, that also we saw yesterday very easily, that I have told you. And then in stress transformation, the logic is that if we rotate the element by some angle, or if we want to see the state of stress at a different orientation, then the transformation concept comes into picture. Transformation is transforming, changing the orientation. Okay. So in the in one of the classes, I have told you, I have discussed this stress transformation with the help of force equilibrium, that how the force equilibrium concept is there. And yesterday what we did, yesterday we developed the equations, that okay, every time we cannot do force equilibrium, it is taking some time. So give me any general equation by which if I simply put the given values and theta values, and so I will be getting the transformed state of stress. So yesterday we saw that also, with the help of a question also we have seen. So so these are the things that we have already discussed in very detailed. I have told you that how the sections are being taken, how the areas are being taken, how theta is being changed. All these things we have discussed in great detail, and I will suggest you that in case if you have not seen the previous lectures, so it's my humble suggestion that you go and please watch it right before watching this one. So yesterday, so I will just write the equations again. So this question we have done yesterday, that is not the problem. Okay, so I will write the equations once again. So the transformed, so given, what will be given? Sigma x, sigma y, and tau xy will be given to you, and theta, that is the change of orientation angle. So if I rotate it, so what will be the normal stress in, let's say, x dash direction? It will be sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. And what will be tau x dash y dash? Minus sigma x minus sigma y by 2 sin 2 theta plus tau xy cos 2 theta. And you know that if I have to find sigma y dash, so what we have to do? We have to simply substitute theta plus 90 in this equation and I will be getting sigma y dash. What is the meaning of all these things? We have already discussed yesterday. So this equation will come out to be cos 2 theta minus tau xy sin 2 theta. Now I wanted to know that on which plane this value of sigma x will be maximum, the value of normal stress will be maximum. I wanted to know. So I already had the equation with me. I can simply differentiate it with respect to the variable theta and put it equal to 0 and I will be very easily getting it, right. So when I differentiated this equation, that is the sigma dash equation, when I differentiated d of sigma x dash with respect to theta and substituted as 0, so what did we got? We got tan 2 theta p. So p I am writing just because it I will give the name of principal. We will get as tau xy divided by sigma x minus sigma y by 2. This is the equation tan 2 theta p we have got. I have also discussed with respect to, I have plotted it on the graph also, and over here two values are possible, 2 theta p1 and 2 theta p2, and both are separated by an angle of 180 degree. For example, if this 2 theta p1 is coming out to be, let us say 60 degree, so this will come out to be, you simply add 180 degree, so it will be 240 degree. Obviously theta p1 and theta p2 will be simply the half of this 60 degree and 240 degree. Okay, Anuj, strain gauges question. Okay, Anuj, let me tell you that I am discussing this is the foundation series. So not specifically strain gauge, a particular topic I am not dealing. Let's see if time permits, we can definitely discuss. Okay. So the angle between them is 180 degree. So what is the angle between 2 theta p1 and 2 theta p2? 180 degree. So if I ask you what is the angle between theta p1 and theta p2, it will be 90 degree. Okay. One more thing I wanted, so I got the planes, so I will substitute in the equation of normal stresses. So sigma 1 and 2, I will be getting sigma x plus sigma y by 2 plus and minus root over of sigma x minus sigma y by 2 whole square plus tau xy whole square. So clearly you can see plus minus, so one value you will be getting as sigma 1 and one value you will be getting as sigma 2. So these are nothing but these are called the principal stresses. These are called the principal stresses, and the plane, that is the corresponding plane 2 theta p1 and 2 theta p2, these are called the principal planes. All these things we have discussed yesterday, and the difference between the principal plane is, with respect to 2 theta angle you can say 180 degree, but with respect to theta you can say 90 degree. That thing we have already discussed. One more thing we have observed that the value of tau xy, tau x dash y dash with respect to this theta plane, that is on the plane of principal stress, was coming out to be 0. So this is an observation. All these are observations and we are simply analyzing the results. So what are principal stresses? The maximum and minimum value of normal stress are called principal stresses, and it has been observed that on the plane of principal stress the value of the shear stress is 0, right. So all these are observations that we are noticing one by one, and once you will do this on your own, the maths you will remember always. Now similar to the normal stress, you might have the desire to find out that on which plane the value of shear stress is coming out to be maximum and what is the maximum value of that shear stress. So let us see maximum in plane shear stress. So logic is clear. I will write the equation of x dash y dash I will write the equation of this x dash y dash, and I will simply substitute for maximum or minimum. I will differentiate with respect to theta. I will differentiate with respect to theta and put it equal to 0. So if you differentiate this, you will be getting minus 2 cos 2 theta minus sin 2 theta 2 and equate it to 0. So 2 and 2 will get cancelled out. So sin 2 theta tau xy so sin 2 theta by cos 2 theta, it will come out to be tan 2 theta, and this will be equal to divided by tau xy minus. So let me give it a name S. Why S? Because these are the planes of shear stresses. So let me give the name S. Okay. So what did we got? We got tan 2 theta S as minus sigma x minus sigma y by 2 divided by tau xy. So if you try to plot it, okay, so if you try to plot it, it will be coming out as something like this. Because see, the minus sign is there. So let's say this is 2 theta S1. So then this distance will be minus sigma x minus sigma y by 2. And this distance can be your tau xy, but again this tau xy can also be negative and that will be positive. So one more possibility is there. one more possibility is there. So this might be another case. This might be another case that this is the tau xy and this is your sigma x minus sigma y by 2. Over here tau xy I have kept as negative. So, the angle you will be measuring, will be with respect to this, and that is called as 2 theta s1, 2 theta s2, sorry. So if I ask you what is the angle between 2 theta s1 and 2 theta s2, so it is clearly you can see that they are separated by an angle of 180 degree. So for example, if 2 theta s1 is coming out to be 60 degree, so you can add 180 degree and you will be getting the value of 2 theta s2, right? Very easily we can find out. So what is the angle between theta, what is the angle between theta p1 and theta p2? 90 degree. What is the angle between theta s1 and theta s2? 90 degree. Both things are very much clear. So this is, one more thing, what is the maximum value? We have determined the planes of maximum in plane shear stress, but what is the value of say tau max? So this thing, from here I can get the value of sine 2 theta s1, I can get the value of cos 2 theta s1 from this triangle, either of the triangles, and then if you substitute over here, so you will be getting the value of tau max, and that will be sigma x plus sigma y by 2, sorry, minus sigma x minus sigma y by 2 whole square plus tau xy whole square. This is the value of the tau max, or it is also called as tau max in plane. It is also known as in plane maximum shear stress. So what is the significance of this in plane? In plane is said because we are dealing in xy plane only, no third plane is there, so it is also called as in plane. Now let us find some observations. If I ask you what was tan 2 theta p, so you will be saying that sir, it is tau xy by sigma x minus sigma y by 2. Okay. So let this be m1, because tan theta is nothing but slope. Now if I ask you what was the case of m2, that is the plane of maximum shear, so you will be saying that sir, it is sigma x minus sigma y by 2 in minus divided by tau xy. So if you take the product of m1 into m2, clearly you are seeing that they are getting cancelled out and it is coming out to be minus 1. So what does this means? This means that these planes are normal to each other. The planes are normal to each other, or the lines are normal to each other. In 2D, plane is represented by line, so the lines are normal to each other. Lines are normal to each other. So one thing you see that what is the angle that you are, be very cautious with the angles. Here we are discussing here it is all related to the angles 2 theta s and 2 theta p. So what I can conclude? I can conclude that 2 theta p and 2 theta s is separated by 90 degree, is separated by 90 degree. So if I ask you what is the angle between theta p and theta s, so you will say that it is separated by how much? Simply reduce it, half it, so 45 degree. Are you getting or not? Obviously two planes will be there, two planes of principal, two planes of shear will be there, right? Two planes of shear and two planes of principal will be there. So all these are small observations. Also one more thing, tau max in plane we have found out, and you will be also interested to know that if there is any normal stress present on this plane or not. So if you find put all these sin theta and cos theta values in the sigma x normal stress equation, you will be getting this sigma x plus sigma y by 2. That means unlike in case of normal principal stresses where tau value was 0, over here normal value is not 0, it is having some value, right? So I hope that these things you people are able to understand. So this is the way of this method of dealing in stress transformation is called the analytical method, because we are dealing with the help of equations. We have developed equations, we have applied the force equilibrium on a 2D element, and then in the plane stress condition, and then whatever equations we have got, we are just analyzing it. So the method that is called is known as analytical methods, right? But it is very easy to deal when when graphically we are able to visualize. So that is why the concept of Mohr's circle comes into picture, right? The concept of Mohr's circle comes into picture. But we should not forget that Mohr's circle is only for 2D, not 3D, right? So now our next topic will be discussing Mohr's circle, and you know that it is one of the most important topics as far as your SOM is concerned. So all these things we have discussed, and I have discussed everything almost, nothing is left as far as the analytical methods are concerned. Now from here cases will come out, that if it's a case of uniaxial stress, then what will be the equations? If it's a case of biaxial stress, what will be the condition? All these things, separate cases are there. But I feel that if you have understood this concept, the general way of dealing stress transformation, then it is just it's adding floors to your already good concept. You will not face any as such trouble in understanding the concept. Okay, so all these things we have discussed, and now let us discuss the concept of Mohr's circle. So first of all, let me draw the diagram. So I am discussing this concept. This is the 2D stress condition, that is the planar stress condition, or 2D, whatever you want to say. And this thing now we will see with the help of circles. So these are the normal stresses that I have shown. For shear stress, let me okay. So okay, shear stress also we are representing. And I have told you already that there are total 3 independent stresses. So for example, this is your sigma x. I need not represent this stress because I already know that it is sigma x. This is your sigma y. I need not write over here that it is also sigma y, it is understood. And any one of these shear stresses I can simply represent by tau, and since it is in xy plane, So I can represent tau xy. Now I need not represent individual, that okay, this is also tau xy, this is also tau xy, because everything is same. By our equilibrium, by our stress equilibrium, we know this concept. Okay. Now what is the thing? The thing is that at different orientations we have to find the value of the stresses. At different orientation we have to find the value of the stresses. By orientation, what I mean is on different planes we are checking that okay, what is the value of normal stress, what is the value of shear stress. What is the value of normal stress at angle 60, at a plane which is 60 degree to, with respect to anything it can be, but now we will fix our reference also. So with respect to that reference, what is at 60 degree, what is the value of normal stress, what is the value of shear stress? Because we know that on every plane, on every face, if we talk about, there is one normal, one shear, one normal, one shear, one normal, one shear. So this thing we have already seen with the help of equation. Now we are trying to represent in the form of circle. Okay, but before coming to circle, let us write the equation that this is, you know, sigma x dash. What is the transformation equation? It was this. This was the transformation equation. Okay. And tau x dash y dash, what was there? Minus so let this be your equation 1, let this be your equation 2. Now can I write in this way? Sigma x dash minus sigma x plus sigma y by 2 is equal to plus sin 2 theta, and then already this is there, tau x dash y dash is equal to okay. So again let me give this as equation 3, and this is same only, but let me just tell equation 4. So what I am going to do, I am going to square this and add this. I am going to square and add this. I am going to square equation 3, I am going to square equation 4 and add them. So if you square them, if you square them and if you add them, so I am not going to do the entire maths because we might run short on time, but I am simply writing the equations directly, that what is the equations you will be getting. When you square and add, this is the equations that you will be getting, right? So generally sigma x and sigma y and tau xy, they are constants and will be given to you. They are constants and will be given to you, provided. So what is the varying thing? What is the variables? The variables will be sigma x dash and tau x dash y dash. Now if you see carefully, it is in the form of a circle. This is the general equation of a circle whose center is a comma b and radius is r. So if you compare both these equations, on comparing both these equations, that means this equation, what can you say? That this equation is in the form of a circle whose center is what? Whose center is, so in place of a you can see that this is there, so sigma x plus sigma y by 2, and here minus 0, b in place of b it is 0, comma 0. So what did we notice? This is the value of the center, and what is the radius? The radius value is coming out to be r square, so r definitely must be so these two things are there. Now if you see carefully, this thing is nothing but sigma x plus sigma y by 2, this is nothing but the average stress, average normal stress. If you see carefully, sigma x plus sigma y by 2 is the average normal stress. Acha, one more thing, just by looking at the center, one thing I can say, that the center will be lying on the sigma axis only. Sigma I will be considering in place of x, tau I will be considering in place of y. So one thing I can guarantee tell you, that the center will be lying on sigma axis only. Now the center coordinates can be 2, 0, 3, 0, 5, 0, minus 2, 0, but it can never be 2, 1, 2, minus 1. So one basic question came, 1 mark question came in GATE 23, where they asked you that 3 figures are given, which of the following does not represent Mohr's circle. So from here only we can tell. Is it clear? Okay, so now let us now we have the center of the circle, we have the radius of the circle, so can we plot the circle? Yes, why not? So first I'm plotting the circle, and then I will show you what are the things. I think this will do. Okay. Is it looking good? Okay. Is it looking okay? Although symmetry is not there, but still we have to manage with this only. Now my dear friends, this is the center. Let's say this is the center of the circle. So center was coming out to be sigma x. I should write only average. Sigma average, that is the center, that is I should write only C, that is the center, and radius is also there, One more thing we should not forget, that we are keeping into reference this equation. this figure. Our reference will be this figure. The normal stress, the shear stress, okay. So this is your sigma x, this is your sigma y, and this is your tau, this is your tau. Now my dear friends, see very carefully, the thing is we have to understand it over here only, that one thing we have to keep in mind, that anti-clockwise shear is taken to be negative in case of Mohr circle. Over here one slight change is there, that when we consider anti-clockwise shear, it will be taken as negative only in case of Mohr circle. This thing you just keep in mind. And one more thing, see now this is the reference. I will show you where is the reference on the circle, but one thing you should note, that on this circle at every point, one point represents one state of the stress. One point represents one state of the stress, okay. But first we have to fix the reference. See, first we have to fix the reference. Reference is important. So one thing I can do, I can consider this sigma x is there, sigma x, this I can consider as the reference, and from here, you know, we can rotate angle theta, in the anti-clockwise direction. So one thing we have to note, that the equation, that the circle equation that we have developed over here, we have there 2 theta was there. While deriving, it was there 2 theta. So Mohr circle, on Mohr circle the angle will be 2 theta. So over here if I rotate by theta, on here it will be rotated by 2 theta, number 1. Number 2, the sense of rotation will be same. For example, here if I rotate by anti-clockwise, here also anti-clockwise will be there, number 2. Number 3, every point on the circle represents one state of the stress. That means at every point you will be getting 1 sigma and 1 tau. 1 sigma and 1 tau you will be getting, that is also very clear. That means on the circumference of the circle, you know, there are lying the stresses, the, you know, each is different planes are lying on the circumference of the circle. And the reference point, now my dear friends, the reference point, see we are rotating from the reference point. Let's say this is A and this is B, one AB plane you are seeing, AB plane will be my reference. And what is the state of the stress over here? Sigma x and tau. Sigma x and tau are the stresses on AB plane. On AB plane, that is the reference plane, that is the reference plane, what is the state of the stress? The state of the stress is sigma x comma, now I should not write tau, I should write minus tau. Why minus tau? Why minus tau xy? Because just now I have told you that the sense of, if it is anti-clockwise shear, it will be negative. So this is anti-clockwise shear, so I have to consider it as negative. So see, if this is your reference plane, if this is my reference plane AB, so if I rotate angle theta, so I can either I can say in this way, either I can see in this way. Second, if I consider this axis as my reference, so if we rotate by theta, so the axis will be again rotated by theta, both are same only, both are same only. Either if you can see with respect to plane, or you can see with respect to theta, matlab axis, plane or axis, both are same only. There is no issue at all, in whatever way you are comfortable. Okay, so let us quickly plot the reference point. The reference point is sigma x minus tau xy. Let's say that sigma x is somewhere around here, sigma x is somewhere around here, sigma y is somewhere around here, okay. But sigma x minus tau xy, so if you, for tau xy it is negative, so I have to move it over here. So what is this value? This value is tau xy. This value is tau xy. So this is my reference. So this is my reference. That is my point A. Let's say I am representing by this AB. I am representing by A. Or if you are getting confused, I can write here sigma x minus tau xy. Now over here I have written tau only, but okay, xy kar lo yahan pe, xy. So this is my, and if you connect it with the center, what you will be getting? You will be getting the radius of the circle. You will be getting the radius of the circle. So radius of the circle, we already know what will be the value. There is no issues at all. No issue at all. So very easily, from the graphical also you can find it. Like you will be know. Achha, what is the coordinate of C? The coordinate of C is sigma x plus sigma y by 2. This is sigma x. So can I find this distance? Yes, I can subtract it and get the value. Do I know this distance? Yes, tau xy. So I can get the hypotenuse very easily. I can do it, but I am not going into that. You can take care of yourself also. Okay, but I know the radius value I already know, and the radius value is coming out to be this. You will get this as your radius value. There is no issues at all. So let me fix, as of now, let me fix this. Why we should fix this? Why we should fix this? Because with respect to this reference plane only, we have to rotate. With respect to this reference plane only, we have to rotate. Now my dear friends, see very neatly. For example, I am considering with respect to axis, let's say. So this is axis. If you rotate this axis by 90 degree, so you will be reaching sigma y. If you rotate this axis by 90 degree, so you will be reaching sigma y wala axis. So on Mohr circle, it will be twice. So that means it will be 180 degree. So if you rotate this by 180 degree, you will be reaching somewhere over here. I know the line is not straight, but just bear with me. So if you rotate by 180 degree, since I rotated in the 90 degree anti-clockwise, so here it will be 180 degree anti-clockwise, and the coordinate of this will be sigma y, that is sigma y, comma, now this is the sigma y. One thing we have forgot, we have to mention the axis also, this sigma, and this is tau, only tau, only tau. So sigma, you know, and on y plane the orientation is clockwise, so it is positive. So sigma y comma tau xy. So see, we have been able to locate sigma x and sigma y very neatly. We have located these two planes very neatly. Now if the basics are clear, you will be able to locate everything very easily. For example, if I have to locate principal stresses, so you know that principal stresses are the stresses on which shear stress is 0. On plane of principal stress, shear stress is 0. So on this entire circle, where shear stress is 0, that will automatically be my principal stresses or principal plane, whatever you want to say. Obviously plane represents theta and stress represents the value. So I can see 2 points, one is this and one is this, where shear stresses are 0, so automatically that will become my sigma 1 and this will become my sigma 2, major and minor, major principal stress, minor principal stress. And obviously, for example, you have from the reference plane, if you go by theta p angle, let's say on rotating theta p, I am getting principal stress. That means on Mohr circle, I have to rotate by 2 theta p. So I can say that this angle will be 2 theta p, 2 theta p1, I can say 2 theta p1. Why? Because Mohr circle will be double. Clear? I know that this one is the sigma 1 axis, principal axis, so I can very easily find. One more thing I can say, if I know the plane of major principal stress, I have to add 180 degree and I will be getting minor principal stress. So if you add 180 degree, this is your sigma axis is your sigma 1. So if you add 180 degree, you will be reaching on sigma 2 plane, that is the minor principal stress. So this angle will be your 2 theta p2, right? One more thing, So on major and minor principal stresses, the tau value is 0, so that also we can find out. Second, if I have to locate the maximum shear stress plane, on which is the point, or which is the point which is representing maximum shear stress. So you know that the angle between principal plane and shear plane is 45 degree. The angle between principal, I'll show you. We have discussed na. 2 theta p and 2 theta s is represented by 90 degree. So if I have to discuss Mohr circle, let us focus directly on 2 theta value, because I know that it is all 2 theta on Mohr circle. So 90 degree, 2 theta p mein you simply add 90 degree, you will be getting the plane of maximum shear. So this one, the sigma axis is your major principal stress value. So if I simply add 90 degree, so I will be reaching exactly over here. So this is the 90 degree, so simply rotate 90 degree and you will be getting the tau max value. And obviously you know that what we have discussed, that on plane of maximum shear there is some normal stress, and that normal stress value is sigma x plus sigma y by 2. The value of the normal stress in plane of maximum shear, it is sigma x plus sigma y by 2. So this we are able to justify over here na, that what is the value of the normal stress? It is sigma x plus sigma y by 2, because that center, it is the center of the circle. So you know that this center of the circle is sigma x plus sigma y by 2. Very easily I can find out. So like this also it is clear. Are you getting or not? Again, the two shear stress planes are separated by 180 degree. So if you travel 180 degree, again you will be coming to this reverse minus r or minus 2 value again. So everything I am able to locate with the help of Mohr's circle. This thing you people are able to understand. That how, first see, if you understand that what is my reference, how I am locating my reference, how I am changing angle in the element, 2D element, and how it is getting reflected on the Mohr circle. If these things, basic things are clear, that means you will be doing any problem as far as your Mohr circle is concerned. Now this circle can come over here, can go over here, but the center will be lying on the sigma axis only. This also we have found out, right? So in my opinion, what are the things that is necessary, that what is the relation between this 2D element and this Mohr circle? If this relation you are able to understand, then I think your basics will be 100% clear and no problems you will face in Mohr circle. This thing I can tell you, right? What is my reference angle? What is the sign convention that anti-clockwise shear is considered to be negative only on Mohr circle? That is the special convention. All these things are the basic things, right? So are we missing anything? No. Reference we have discussed, principal plane we have discussed, shear planes we have discussed, maximum principal, maximum shear. So I think everything we have discussed as far as your Mohr circle basics are concerned, right? Okay. So all this point is very important, that each point on Mohr circle represents the two stress components, right? This thing you have to see once. So my dear friends, what I have to say, that till now I have taken 3 classes on stress transformation, where the journey is something like this, that this 3 hours means 3 classes means is equivalent to 3 hours, and in this 3 hours I have started from a general state of stress, and today I am ending on this circle. So the journey from a single state of stress at a point to this Mohr circle is your complete the concepts of stress transformation. Obviously different cases are there, that if it is a uniaxial stress, biaxial stress, then what will be different things, but that is you can look at it out by your own, that is not the issue. But I think these three classes, if you have seen honestly, completely, then this is my assumption that your basics are at least very much clear, and you will never face any problem as far as any conceptual, as far as your concepts are concerned in Mohr circle or your stress transformation equation. And I have taken exactly 3 classes for this stress transformation because it is one of the most important region or area as far as your strength of material is concerned. Now whether you are preparing for GATE or any other examination or your semester examinations, it's a must watch for every one of you. In case of any doubt, I have been telling this every time, in case of any doubt you can leave your comment in the comment section. If you are finding it useful, that also you can leave it and share it with your friends who are preparing by themselves. It will be a very help for them, right. So over here I will be stopping today, and again tomorrow we will be meeting with some different topic, and with these classes I hope that your concepts are getting clear in strength of materials day by day, right. So let's stop it over here, let's meet tomorrow. Till then, keep studying, keep revising, take care, God bless.